Hi, my name is Shibli Barua, and this is a short presentation that I've made on reaction stoichiometry that is intended for college level freshman general chemistry course. So first of all, what is reaction stoichiometry, or what does it tell us? Reaction stoichiometry provides us with the quantitative relationship between reactants and products in a balanced chemical equation. So if you look at an example, we have sodium hydroxide as the base reacting with sulfuric acid to give us sodium sulfate salt and water. So this is a common neutralization reaction that we encounter in chemistry quite a lot. The first and foremost thing to do is to balance the chemical equation so that we can make use of it and we can get the right quantitative relationship between the reactants and the products. We have one sodium here, two sodium here. So the first thing to do is to put a 2 in front of sodium, and that 2 is going to be called stoichiometric coefficient, and we have to put another 2 here in front of water, as we will go over it, to balance the chemical equation. So we have 2 sodium on the left hand side, we have 2 sodium on the right hand side, we have 2 oxygen on the left hand side. We are disregarding this oxygen and sulfate because we're going to consider sulfate as a whole later on. So we have 2 oxygen on the left hand side, and we have 2 oxygen on the right hand side. We have 2 hydrogen plus 2 hydrogen over here, so 4 hydrogen in total on the left, and 2 2s are 4 hydrogen on the right. Then we are going to consider the sulfate ion, or sulfate, all by itself. So 1 sulfate on the left and 1 sulfate on the right. So this chemical equation is balanced. Now we can make use of this balanced chemical equation to solve problems. So let's look at some examples. The first example tells us how many moles of sodium sulfate, the salt, is produced from 100 milliliters of 0.5 molar sulfuric acid, provided all the acid gets used up in the reaction. So the sulfuric acid is the limiting reactant in this case. That means all of the sulfuric acid will be used up at the end of the reaction. The first thing to do is to gather as much information as possible from the question itself. The question gives us 100 milliliters of 0.5 molar sulfuric acid. So just by looking at it, we can find out the number of moles of sulfuric acid from this question. Once we find out the number of moles of sulfuric acid, we can use the stoichiometric equation to find out the number of moles of sodium sulfate. Now what does this equation tell us? This equation tells us that if we have 2 molecules of sodium hydroxide and it reacts with 1 molecule of sulfuric acid, it will give us 1 molecule of sodium sulfate and 2 molecules of water. We can extend this from molecular level to a large number of particles, a large number of molecules. Obviously we cannot separate out 2 molecules and 1 molecule. So what we do is we extend it to number of moles. Now 1 mole equals 6.022 times 10 to the 23 units of something, roughly. So if we have 1 mole of sodium hydroxide, we will say that we have 6.022 times 10 to the 23 units or molecules of sodium hydroxide at our disposal. So if we have 2 moles of sodium hydroxide, we will need 1 mole of sulfuric acid to produce 1 mole of sodium sulfate, and it will also give us 2 moles of water. So we have volume and molarity of sulfuric acid. We can find out the number of moles. What is the equation for, or what is the equation for number of moles? Number of moles equals volume in liters times molarity. So let's try to solve this problem. We have milliliters of sulfuric acid, so we can convert it to liters first, and we know that the relationship between liter and milliliter is 1 liter of anything gives us 1,000 milliliters. So we have to multiply the volume of sulfuric acid that is given to us with this ratio. Notice that milliliters of sulfuric acid is put down at the bottom so that it actually cancels out, and what we will be left with is liters of sulfuric acid. Once we find out the volume in liters of sulfuric acid, we have to multiply it with the molarity, which is given to us to find out the number of moles of sulfuric acid. Now what does 0.5 molar means? 0.5 molar means that if we consider, or if we take 1 liter of sulfuric acid, that will contain 0.5 moles of sulfuric acid molecules. So that's why we're going to use this ratio and multiply it with the volume of sulfuric acid that we have to find out the number of moles. So from here up to this point, this whole thing will give us the number of moles of sulfuric acid that has been provided to us. So we have 0.5 moles and 1 liter down at the bottom. 1 liter, this liter of sulfuric acid, liter of sulfuric acid will cancel out, leaving us with moles of sulfuric acid. So we're going step by step. First we have determined the volume in liters, then by adding, by multiplying with this ratio, we have found out the number of moles. Now we are not done yet, because after we find out the number of moles of sulfuric acid, the final question asks us to find out the number of moles of sodium sulfate. So we have to look at the relationship between number of moles of sulfuric acid and number of moles of sodium sulfate. And where can we get it from? From the balanced chemical equation. The balanced chemical equation tells us that 1 mole of sulfuric acid will provide us, or will produce 1 mole of sodium sulfate. So that's the ratio that we have to multiply with the first part. So 1 mole of sodium sulfate is equivalent to 1 mole of sulfuric acid in this balanced chemical equation. So if we multiply with that, as you can see, mole of sulfuric acid and mole of sulfuric acid will cancel out, leaving us with moles of sodium sulfate. So let's see how the units cancel out. So we have milliliter, milliliter canceling out. We have liters, liters canceling out of sulfuric acid. Moles of sulfuric acid, moles of sulfuric acid canceling out. What we are left with is the final answer, which is the moles of sodium sulfate, and that's what we are trying to find out. So if we multiply all the numerators and divide by the product of the denominators, we can get to our final answer, which is 0.05 moles of sodium sulfate. Okay, let's look at another example. So we have looked at the relationship between sulfuric acid and sodium sulfate. What about the relationship between sulfuric acid and sodium hydroxide? So let's look at another example that describes that. So what mass in grams of solid sodium hydroxide this time is needed to react with 100 milliliters of 0.5 molar sulfuric acid? So it's the same quantity, same amount that we had in the previous question for the reaction to be complete. Once again, we have to look at a bunch of ratios and a bunch of relationships to get to our final answer. The first part is exactly similar, exactly the same to what we had in the first problem. So we, over here once again, we are determining the volume in liters of sulfuric acid, then we are multiplying it with this ratio to find out the number of moles of sulfuric acid. This time, we have to determine the relationship between sulfuric acid and sodium hydroxide. Or we're going to have to use the relationship between sulfuric acid and sodium hydroxide. The mole ratio in this case is 2 moles of sodium hydroxide per mole of sulfuric acid, which we obtain from the balanced chemical equation. Once again, moles of sulfuric acid goes down at the bottom, moles of sodium hydroxide up at the top, because that's what we are trying to find out first. So we found out moles of sodium hydroxide up to this point, and then you have to multiply that moles of sodium hydroxide with the molar mass of sodium hydroxide to find out the mass in grams. And how are we going to find out the molar mass of sodium hydroxide? It's very easy. You just go to the periodic table, look at the relative atomic mass of sodium, which is 23, relative atomic mass of oxygen is 16, and relative atomic mass of hydrogen is 1. So if you do 23 plus 16 plus 1, it gives you 40, and all you need to do is to just add a unit of gram right next to it. So that's how we can find out the molar mass of any molecule or any compound. So molar mass of sodium hydroxide would be 40 gram, and we are using this ratio once again. 40 gram of sodium hydroxide is equivalent to 1 mole of sodium hydroxide. So if we use that ratio, and once again we can cancel out the units. Once again, milliliters cancel out, liters cancel out, moles of sulfuric acid cancel out, and this is an extension. So this moles and this mole cancel out, leaving us with the mass in grams of sodium hydroxide that we are intending to find out. If we multiply all the numerators and then divide by the product of the denominators, we're going to find out the final answer to be 4 grams of sodium hydroxide. So what have we learned from this short lecture? So in summary, first of all, we have to start with a balanced chemical equation. If we have been given an equation, we have to make sure that the equation is balanced, first of all, in order to get the correct picture, in order to get the right quantitative relationship between the reactants and the products. Then we have to make use of the information provided. In our case, we had 100 milliliters of 0.5 molar sulfuric acid, so we used that piece of information to start off our, to start tackling our problem. Number 3, set up the ratios so that the different units cancel each other out, and the final unit or answer survives as the numerator. We have already seen that. In problem 1, our final answer was in terms of moles of sodium sulfate, and in the second problem, our final answer was in terms of grams of sodium hydroxide. So we had to keep moles of sodium sulfate as well as grams of sodium hydroxide at the numerator so that it survives as the final answer. We should not forget about the mole ratios. Mole ratio is very, very important. In many cases, mole ratio is 1 to 1. In this case, 1 mole of sulfuric acid versus 1 mole of sodium sulfate. However, we have 1 mole of sulfuric acid is equivalent to 2 moles of sodium hydroxide. So that will skew the results. If we don't consider that, we will actually get to the wrong answer. So make sure that you consider the mole ratios. It's very important. Then finally, if you want to find out mass in grams of something from the number of moles, we have to convert the moles to grams by using molar mass. All we need to do is take the number of moles and we have to multiply it with the corresponding molar mass to find out the mass in grams. Hope this short lecture was helpful to you, and thank you very much.